Alright, in this video I'm going to talk about covalent bonding. So in the last unit we started talking about bonds, and we did this by introducing ionic bonds. So in general, a bond is a force that is going to hold atoms together in a compound, or a group of atoms together in a compound. And ionic bonds are actually when an electron is transferred from one atom to another. So that's why we learned all about ions, cations and anions, and the movement of an electron from a metal to a non-metal creates a charged particle. So you either have a positive charged particle or a negatively charged particle, and the opposites charges of those atoms is then causes them to attract together in the form of an ionic bond. Now, if we talk about an ionic bond or an ionic compound like sodium chloride, for example, sodium chloride is 1 sodium per every 1 chloride. So the smallest whole number ratio, or the formula that you've written, is actually called a formula unit. Now, covalent bonds we're going to talk about in this unit. So covalent bonds are actually when, instead of physically transferring an electron from one atom to another, the electrons are going to be shared. And when two atoms do this, they are called a molecule, or covalently bonded compound. And again, remember that they're trying to achieve stability by having 8 electrons in their outermost shell. So if we look at this example here, so we looked at this before in a previous video, you've got sodium, and sodium has 1 valence electron. Chloride has 7 valence electrons. And so sodium's going to give up its electron to chloride, and then it would be a +1 because it's gotten rid of an electron. And chloride would then be a -1 because it's got 1 excess electron. And then they are attracted to each other because they are oppositely charged in a ionic compound. Now, if we look at this in terms of a covalent bond, remember that ionic bonds are between a metal and a nonmetal. Covalent bonds are between 2 types of nonmetals. So nonmetals tend to want to hold on to their valence electron. So remember, they are up and to the right on the periodic table. If they're going to become ions, they tend to pull electrons to themselves, and they don't want to lose those valence electrons. So if 2 of them are going to come together in a bond, we're not going to give away electrons, but we still want to achieve that octet, or that 8 valence electrons. So they do this by sharing. So let me just give you an example. So let's say we have 1 fluoride, or 1 fluorine, right? And it's got 7 valence electrons because it's a halogen. It needs 1 more to have a full, 8. Then if we had a second one that has 7, if they came in close proximity to one another, they could actually share that last electron, and by sharing, they would both end up with full s&p orbitals, or a full 8 electrons. So this fluorine has 8 valence electrons, and then this fluorine also would have 8 valence electrons. So by sharing, they achieve that noble gas configuration. Now, covalent molecules actually have lower melting points than ionic compounds. The attraction between oppositely charged particles is a lot stronger than the sharing of electrons in a covalent bond. So ionic compounds have a stronger bond than covalent compounds. And one of the labs that, you may have already done it, but if not, one of the labs that we're going to do is making caramel. And so what that tries to demonstrate is the relative high melting point of ionic compounds versus covalent compounds. So we actually melt sugar on a hot plate, and sugar is a covalently bonded molecule, whereas ionic compounds like salt, even though table salt looks very similar to sugar, it takes like a blowtorch to melt salt. It melts at an extremely high temperature. So ionic solids are typically brittle, let me flip back. Ionic solids, we learned, are typically brittle, and they have this sort of network of positive and negative ions that are all attracted to one another, which makes the bond even stronger. So not only is it strong between a positive and a negative charge, but also the fact that, like this was sodium chloride, if this is the sodium, notice that when it's in its sort of crystal ionic structure, it is is surrounded by negatively charged ions, which is why the melting point is so high and it's so difficult to, sort of break that bond compared to covalent bonds. Now, typically, ionic bonds are solid or crystal at room strength, at room temperature. Covalent bonds and covalent molecules tend to be gases or liquids at room temperature. So, like water and carbon dioxide and sulfur dioxide, those are either gases or liquids at room temperature. Some are solids at room temperature. So, for example, sugar that we use, that is a covalently bonded compound, but it's a solid at room temperature. So that just kind of gives you an introduction to a covalent bond, the idea of sharing electrons, and some basic properties. And we'll go more into detail of the properties of a covalent compound in the next videos.